Hello, everyone, and welcome to today's panel discussion. On behalf of American Petroleum Professionals of Iranian Heritage, APPIH, it's our great honor to start another session of for panel discussion. The title of the today panel discussion is Applications of Data Science in Petroleum Engineering and Beyond. Before starting, two short points. During and after discussion, you can write your question in the chat box. And the second, beside today panel discussion, we have the announcement of the winner of yearly APPIH scholarship today. Moderator today will announce their name. And let's introduce today moderator. It's our great honor that today we have Dr. Khoshghadam. He has significant experience in reserve estimation, numerical modeling, and data analysis. Currently, he's working for New Dawn Energy Company. I would thank Dr. Khoshghadam for accepting our invitation, and without further delay, I'm transferring microphone to him for starting the panel. Thank you.
Thank you so much, Hamid-Jan. Hi, everyone. Thank you again for joining us today. I'd like to thank American Petroleum Professionals of Iranian Heritage APPIH team for hosting this event, especially Mr. Hamid Reza Samoui and Mrs. Simin Sadeghi. Please follow APPIH on social media platforms such as LinkedIn, Twitter, and Instagram. And please don't forget to check the APPIH website. Please help them in any way that you can, such as sharing their posts, like their posts, and making donations. Before we start the panel, like Hamid said, I have an exciting announcement regarding the APPIH scholarship program. On behalf of the Board of Directors of American Petroleum Professionals of Iranian Heritage, welcome to our annual meeting. This meeting is the annual occasion when we recognize and grant a one-year scholarship to three of many outstanding Iranian graduate students studying in US universities. The selection of winners is always a difficult task since there are so many truly outstanding Iranian students pursuing their graduate studies in this country. The winner of this year are as follows. Mojtaba Mohasseb, he's a PhD student at University of Louisiana. Mohammad Ehtamam, he's a PhD student at University of Houston. And Wahid Sabzevari, he's also a PhD student at Texas Tech University. Congratulations to all of our winners. Keep up the good work. Also, APPIH board is asking for your help with following matters. First, young members' participation. This is the same as above. We need to increase the participation of recent graduates and students in APPIH activities. Aside from helping us, volunteering gives you a valuable experience in teamwork and leadership that will help you with your career development. In fact, volunteer activities are one of the important measures for scholarship awards. Please contact any board member and let us know of your interest. Second, fundraising. APPIH depends on the financial contributions of its members to pay for the administrative expenses, as well as the... Oh, I appreciate if you could mute your microphone. So the second one was the fundraising. So none of the APPIH board members or volunteers is paid directly or indirectly for their work. Please note that this, since APPIH is a non-profit organization, your donations are tax deductible. Third, some companies have a donation matching program for encouraging philanthropic contributions by their employees and promote their participation in social activities outside the company. This is a very effective way of doubling contributions while at the same time letting the employer know that you are socially responsible and also socially distancing. Please visit the APPIH website and update your contact information. We need this information to be able to keep you informed. Fifth, you don't need to be a member of APPIH to participate in our meetings and activities. Our limitation is that APPIH APPIH funds need to be spent within the United States. Our friends in Canada are always welcome to join our meetings. We will keep them informed of our activities and meetings if we have their contact information. Again, congratulations to this year's winners and all of you that supported us. We are looking forward to your involvement in our future activities. Let's go and start our panel. So our today's panel is a roundtable discussion on the application of data science in the oil and gas industry. We'll talk about 4 different topics for about 15 minutes, and in the end, we'll open the discussion to our audience to ask questions. We have talked about some of these topics in our past panels, but today our focus is on data science application. Please mute your microphones during the discussion and send your questions through the message box. Let me start our panel by briefly introducing our panelists. Our 4 panelists all have classical petroleum engineering education and working in a different fields of data science. Our first panelist is Professor Shahab Mohaghegh. He's a pioneer in the application of artificial intelligence and machine learning in the petroleum industry. He's a professor of petroleum and natural gas engineering at West Virginia University and the president and CEO of Intelligence Solutions. Professor Mohaghegh has a bachelor's, master's, and PhD degrees in petroleum and natural gas engineering. He is currently the director of WVU Leads, which is the West Virginia University Laboratory for Engineering Application of Data Science. He is a SP Distinguished Lecturer in 2007 and 2020 and has been featured 4 times as a Distinguished Author in SP Journal of Petroleum Engineering. He has more than 200 technical papers and carried out more than 60 projects. Thank you, Dr. Shah, for joining us today. Our second panelist is Belyadi, a very good friend of mine. You probably have seen Haas if you had a chance to join us in our previous panels. Haas is a senior data scientist and engineer at Vine Oil and Gas. Additionally, he's the founder and CEO of Observelligence, focused on providing artificial intelligence in-house trainings and solutions. Haas has served as an adjunct faculty member at multiple universities, including West Virginia University, Marietta College, and St. Francis University. He's the primary author of the hydraulic fracturing in unconventional reservoirs. Haas has earned his bachelor's and master's degree in petroleum and natural gas engineering from West Virginia University. Haas is also have another panel discussion, so make sure to follow him and then like his panels, they are really informative. Unfortunately, Morteza Naraghi, our third panelist, he had some family emergency and couldn't join us. We have, well, praise and thoughts to him, and hopefully everything's gonna be okay. Our last panelist is a good friend of mine and my college classmate, Mehrdad Shirangi. Mehrdad works as a staff data scientist at GE. He works with GE product lines in various projects to develop continuously updated machine learning models, digital twins, and perspective analytics for optimal operations. Mehrdad has a master's degree from University of Tulsa and a PhD from Stanford University, both in petroleum engineering. Thank you all for joining us today. Let's jump to our discussion with our first questions. Here's the first question. Do you have any first-hand experience with the changes that data science has made on your projects or work environments? Let's just start with Dr. Shahab.
Thank you for this invitation. And first and foremost, I'm very happy to see Dr. Behruz Fatahi here. It's a pleasure seeing you, sir. I haven't seen you for a very, very long time. And I'm sure you all know that Dr. Fatahi is one of the major people who started this organization, APPIH. Thank you for his presence. With that, regarding the first-hand experience, that what changes, to be very honest with you, this technology completely has changed my life. It goes back to 1989, after something very horrible happened to my family. And I was in US at the time, was a graduate student at Penn State. And once I found, and my sister was involved in it, and we were very close. And after a year, I learned that she was able to handle the problem that was going on. And I asked her what happened, and she said, meditation. And that created a big question in my mind. And so I started learning what meditation does. And it has to do with the fact that I started learning how human brain works. And for a very long time, this was purely a personal issue, had nothing to do with my work at the university. This happened until 1991, when I was at WVU. We solved the problem. We had a project with DOE, and we concluded that cannot be solved using statistics. And we wrote a paper actually on that. And then I brought in a graduate student from Iran at the time, Sharif University grad student. And I asked him whether he would like to work with me on using, it was not called AI and machine learning at the time. It was neural network, whether we can solve this particular project that DOE was had given us, and we have concluded that cannot be solved. And we used neural network to do that. And it was a lot of data. It was what we called virtual measurement of permeability from well logs. And it was very successful. And the paper was published in 1993 on the topic. And that completely changed my life. Since then until today, I have not done anything or any research or any project that did not involve this technology. So the answer to this question is yes, it has changed everything for me, and it's no longer, one thing I've learned is there is a completely different way of solving engineering related problems. And that is not to use the traditional approach that we learned from all of you guys are engineers. As you started, you learn how to solve physics or how to model physical phenomenon using traditional approaches. This technology gives you a completely different approach to do the same thing. So I'm going to stop right there. And if you want any more detail, I'm really happy to share.
Sure. Let's have Haas also. Well, what about you, Haas? I know you working seriously with data in oil and gas, but what changes have you seen, for example, in the past 3 to 5 years?
Yeah, sure. So I'll start off, going back to probably 2014, I would say, right? So in 2014, I was analyzing, I was an engineer, I believe it was CNX, and I was analyzing, about 500 wells back then. And, every single well had a different design. One had, different proppant per foot, different well spacing, different types of design that you could not possibly sit down and compare, okay, we pumped this job on this well, and then this job on this well, and this well is acting better. There have been so many changes within the same well, so it was very hard to analyze those wells, right? So then we said, okay, what else can we do to build a type of a supervised machine learning model, as opposed to just looking at it from, okay, this pad is performing better than this pad, what can we do to use a supervised machine learning model to actually find trends and pattern in the data, And that's when we started applying, machine learning to kind of train a model and then find patterns in the data and kind of understand and qualitatively and quantitatively understand what is the impact of each parameter on the EUR per foot or on the cum production per foot. That was on the drilling side. Or I'm sorry, that was on the completion side. Now there are other applications. When you look at, for example, drilling side, in drilling we have a lot of high frequency data. You have, as we drill a well within the lateral, within the curve, you have different parameters such as weight on bit, torque, differential pressure. and so on and so forth that you're constantly getting. So actually, if you look at each file, there's a ton of data, right? And then the goal in drilling is to maximize your ROP, right? If you can maximize your ROP when you're drilling a formation, that's the ultimate goal, right? So you can also apply, you know, since this data becomes so much, and human cognition is no longer able to decipher information from that data, then you can apply, for example, some type of a supervised, you know, machine learning algorithm to, you know, to have your inputs and the output would be the ROP. And then once you build your supervised model, then you can go towards optimization and use other techniques such as genetic algorithm, particle swarm optimization, and so on and so forth to optimize your ROP, for example. So that's on the drilling side. So let's just talk about, for example, on the geology side. You know, we have like well logs, you know, and I'm sure Dr. Shahab and the rest of the panel have had a lot of publications on this. You know, you want to, let's just say you want to predict your, you know, again, these are like a lot of like publications on these. You know, let's just say you want to predict, you know, and you want to, you know, build a model to predict your shear and compression wave travel time, to predict your geomechanical properties. You know, well, we have all these sonic logs, you know, from, let's just say 20, 30 wells that you can train a model on, and then be able to predict those shear and compression wave travel times to be able to predict your Young's modulus, Poisson's ratio, and so on and so forth, you know. And it also on the seismic application, you know, if you want to just, let's just say, find your faults, you know, you can use deep learning, you can use the recurrent type of neural network to find you know, that are kind of used for image and voice recognition. You know, you can use those types of models on the geologic side. On the production side, you can use machine learning, for example, for, you know, plunger lift optimization, you know, so there are, as you can see, there are different applications, and really all of this, you know, goes back to, you know, my background has been reservoir like engineering. You know, I've been a reservoir engineer for for a long time, and all of these problems that you can find within any organization goes back to really one aspect. It's just your domain expertise. You know, if you understand a problem, you can apply it to anything really, as long as you understand what you're trying to solve, what the objective function is. You can apply it to really any problem to solve. You know, to like to kind of solve it. And so really a lot of this just goes back to what you're trying to solve, and really there are, you can find so many different applications. You know, might be small, you know, these are the examples that I gave. These are some of the major applications, but there are other applications that could be smaller. You can apply this to.
Let me ask the same question from Mehrdad. I know you're leading several projects in G. Also, he has like 25 different publications, mostly related to the application of data science in oil and gas. So what about you? What first-hand experience you have with the changes of data science?
Sure. Hello, everyone. Thanks, Mohammed, for the question. And you know what the question I think is about like how the oil industry is adapting data science. Honestly, I think the industry has changed significantly from say 5 years ago. You know that if you think about oil and gas industry, you have the upstream operations, you have the downstream, and you have the midstream. And all the companies in the oil and gas industry are developing products and providing services that are based on data science. And when we talk about data science, it's not just machine learning or automated machine learning, which is the new paradigm, or auto ML or auto deep learning, automated deep learning. These are just one set of techniques within a broader range of techniques that are called data science. So it all comes from creating value from the data itself without developing detailed physics-based models or simulations. So the industry is changing a lot, and the parts that I have seen, I mean, everything that I've been doing in the past several years is based on is towards developing services and products that are based on machine learning and data science. And so if I give you an example, is that if you think about reservoir engineering, which is something we have all studied in petroleum engineering education, you typically develop like a simulation model, and you try to understand how the rates and production varies when you change parameters of the field development or the production scenarios that you have. Whereas when you think about data science, it's much broader. Like reservoir becomes just one particular application of the techniques that you have mastered. And so the industry is changing a lot. And if you think about data science, it's all about data. So how do we utilize the data itself to go from data to a set of recommended parameters? In reservoir engineering now, we utilize the data to see what is the optimal set of parameters to frack a well, and a project that I've done for Diamondback Energy, and a project that we did for Hess. If you think about like drilling, everything is going towards remote operations. And when we talk about remote operations for drilling, we have to be able to interpret the data in the real time, utilizing the models that are trained on the past historical data, and provide recommended parameters about bit BHA selection and the parameters to set in terms of RPM, mud flow rate, mud type, etc. At the rig site automatically without having to have the personnel on the rig. If you think about midstream operations, the transportation of oil and gas, so fluid in the pipes, people are now developing models based on deep learning and image recognition to understand when a corrosion is happening on the pipes based on the images that they take. So they try to provide services that are based on trained models on the various elements of pipe maintenance. If you go to the downstream, all the sensors on the platform, they provide, like you have tens of thousands of sensors on the platform that they measure the pressure and temperature and the valve rate and at various parts of the platform. And we need to have predictive maintenance and have products that provide those. So the industry is really, really changing, and every company in this business is trying to catch up and not to fall behind, and either build their products and services that provide data science-based values and
yeah, that's correct.
Yeah.
Well, thank you all. I mean, you guys almost covered my second questions, and which I'm going to ask. But the petroleum industry, like, upstream, is not is familiar with data. For example, the seismic, we have a ton of data for the seismic, 3D seismic. So the concept of the data is not something new, but how to look at it is something new. How to look at it and interpret it, for example, in terms of the mud for the drilling or hydraulic fracturing. So I know that's new. That's what is we are asking for that. Okay, how do you see that these new applications has changed, has made changes in these areas? So that comes to my second question, is that which sectors of the industry has adopted the data science concepts in its daily operations? So, and then what sectors do you guys think has the highest potential in terms of the helping the industry, in terms of the making more money, new companies coming and then working on those aspects? So I'll start again with Dr. Shahab.
Okay. Honestly, I don't know the answer to that question. Which sectors have the highest potential? I think it makes sense only to answer that question if you have experience in all of the different sectors, and then you make a decision. I don't have that, so I cannot provide you with an answer to that. But what I can share with you is what I'm involved with, which is to a very large extent has to do with reservoir engineering part. Well, just very quickly, let me tell you that I have been involved with drilling application and ESP, artificial lift application, and which provided a very fantastic insight to me. And that was just to share a little bit of it with you all, is that once you start working in a realistic fashion with this technology, one thing you immediately will learn, well, not immediately, but if you get access to these type of approaches, one thing you learn is that there is a big difference between what's called big data analytics and data analytics. In other words, when you work with reservoir engineering, you don't have big data. But when you would work with drilling, yes, you have an access. There is a possibility for you to have big data. When you deal with artificial lift, you have access to big data. And if you think the same approach will work in both cases in the same fashion, then you will be surprised in a way that you'll find out that that's not the case. That's one thing. So, but my main area is reservoir engineering, and the way it's being handled, unfortunately, in our industry, I disagree to a certain extent. My experience tells me that a very large percent of people in our industry, especially in all the operating companies, they do not necessarily understand what this technology can do. And when you go to them and when you ask them to do this, so the key behind this technology today that we have this panel for, it's because it's a very sexy technology. Everybody talks about it.
Exactly. That's right.
But that at the same time causes a big problem. And the problem it causes is people end up thinking that as long as I use this terminology, then I'm going to be okay. Well, unfortunately, that's not the case. To very large extent, as I've been exposed to, the understanding of this technology is very, very superficial in our industry. And that is why the advancement of this technology in our industry has been very, very slow, because the managements will end up spending a lot of time and resources, a lot of money, and then what they receive in return as an output is sometimes really bad, and in best cases is very, very mediocre. And then what they do, this goes back actually in our industry back to early 2000. I'm not sure how much you are familiar with that, but at the very beginning, one of the companies that used this technology, I don't know if we should name it or not, but the company that's headquartered was in very close to San Francisco, so we all know which one it is, right?
Yes.
Yes. So what they did, they actually hired people from Google. They ended up paying them tens of millions of dollars, and after 2-3 years, what those top data scientists of Google ended up telling them was that, and they literally, this company provides, it's an international company, all of you know, they provide an incredible amount of data that they have. And what the top data scientists, experts of AI and machine learning, they told them that after this time, we learned that the more porosity you have, the chances are the amount of oil that you're exposed to is much more. And these people's jaw dropped. Said, wow, you spend tens of millions of dollars to get that? And it had a lot to, and this is true. And don't, if you don't believe me, you go actually ask them in person. I tell you which company it is, and I actually give you the people that exposed this.
No, it makes sense. It makes sense. I mean,
yeah, because and then the key was when that happened. I don't know if you have listened to a Petro talk that I have. This on YouTube. Just put my name and. You'll see it. That Petro talk, it's very short, it's only 11 minutes. I talk, the people who are there in that meeting are all professors from every single university in the US and from some other, and then we had some head of SPE there. And the key that I mentioned, that I've been mentioning for 2 decades, was that in order for you to be able to use this technology correctly in our industry, you must have domain expertise. And one of the major problems at the beginning, in the year 2000 till 2005, was that people were using AI experts that then they would get the data, incredible amount of data, and they try to figure out how they can help it. But because they didn't have domain expertise, the results were not good. And for 2 decades, I was telling them that you need domain expertise. And a lot of people believe that right now. But now we are in completely the opposite part of this, which is, in my opinion, not very good. And that is, yes, you must be a domain expert, but please do not think that if you watch a video on YouTube or read a book or read a paper, then you become an expert in AI and machine learning. That is one of the major issues that we're dealing with, unfortunately, and that is what's causing this lack of enhancement of this technology in our industry. It's going to take some time. We're not there yet. We are way behind it, and right now it is from mainly, as I said, it's because it's a sexy terminology that is used. It has not shown its real value to our industry, and the best people that you need to talk to and get their opinion are the managements that have spent a lot of time and money and resources, and then they are really upset with what they have done or what their manager before them did that.
Thank you, Dr. Shah. Before I ask Haas for his comments, so for myself as a personal experience, I have to name this company Drilling Info. So this company has changed how we look at the offset and the data, especially for myself. Look, and now we have access to much more data, and then we could look at, for example, just a small example is the offset data, that how they do, and then provide that data much faster and a trends for us. But it's a totally different, type of data or, things than the whole AI. Just want to say that, things like that has helped, for example, myself as an engineer to see the data, to look at them. But I know, in oil and gas, we have about, how many wells we have in US? I think 3 million, something like that, more than that. But in terms of the human applications, like the other companies, we have 300 millions with different activities every day that they need to look at it. So probably we need a different approach. But I'll let Haas to talk about it, and then what do you think about this topic?
Yeah, sure. I think one of the areas that has, like in the past, let's just go back to the past, right? So we've trained, let's just say we've done different analysis train different models in different areas within the, let's just say, the upstream and midstream section, right? And those have all been static models. And what I mean by static models is that, these models, we just, train a model, found patterns in the data, made a decision and moved on. That has been at least my primary experience with it. You train a model, find patterns in the data, report it to the management, here's what we see in the data, and so on and so forth, right? I think one of the areas that has a lot of potential is how can we take now these models that we develop? Let's just say you train a model in any, let's just say on the drilling side, okay? And you're happy with the model, with the model accuracy, you applied a bunch of blind set wells and sets, and everything is turning out to be great, okay? You're happy with the model. Now, what can you do with this model to deploy it real time, right? And deploying this model real time, requires some type of an edge device or edge computing, right, to do that. So I think in the next few years or in the next 5 years, again, this is just my personal opinion, you're going to see a lot of these models that are being trained go on to be deployed on an edge device real time, and then make decisions real time. So let's just say I'm going to go and drill a well. I don't want to wait until the well is drilled and then know if I drill this well optimally or not. I want to actually be able to drill this well, change the drilling properties, drilling features or parameters that optimizes and maximizes the ROP on a real-time basis. I don't want to wait after like everything is done and then analyze it, right? So I think the application of taking these models and coupling them with an edge device in order to deploy real time is going to have a lot of popularity, a lot of applications in the next 5 years. That's where I think it can really add some value, depending on the application. Like especially in areas where you have a lot of data, where you're getting a lot of data, such as, for example, on a drilling site or on the production side, where you have a lot of high frequency data coming in. What can I do to detect issues, detect problems, real time to fix the problem immediately, as opposed to waiting a week, waiting like a few days. Oh, my well is loaded. Can you actually, like, here's an example. Can you actually deploy a model real time to detect, for example, when your well becomes loaded, to detect when your well has issues, on a real-time basis, as opposed to just waiting, I'm going to go analyze these wells and so on and so forth. I think that's, and to do that, you need to go into the field and like edge device is simply a mini computer, okay, that is designed for harsh environments. Okay, you install these edge devices on different sites, whether you're on the production side, drilling site, or wherever you're at, and that edge device can collect the data, and also you can directly deploy your machine learning model on those edge devices and then make decisions real time. Again, this is my opinion. I think in the next 5 years, you're going to see a lot of applications of deploying these machine learning models on the edge device to make real-time decisions. Will gain a lot of popularity and could potentially add a lot of value to a lot of the organizations.
Okay. Mehrdad, what about you? You work for a service company, and I believe that data science, application is becoming one of your product lines, especially, and then you guys are gathering a lot of data. For example, when you're running a frac job or drilling a well. So the question was like, which sectors has adopted the concept, and then which sectors do you see that the highest potential in terms of using data science, in terms of making money?
Sure. As in a broader sense, I think every part of the industry has the potential to be benefited by data science and machine learning. And obviously, it doesn't require a lot of discussion. If you just search for the jobs in oil and gas, you see a lot of ads for data scientists in different sectors, midstream, downstream, and upstream. Every single company is hiring data scientists, and they want people who have skills in both data engineering sometimes and data science. And data engineering is different from data science, and data science is a little bit different from machine learning engineering. And we've been, being data science team, we've been hiring data scientists as well. And so it's like the industry is really changing in all its segments. And which part has the highest potential? I would say, you know, every part of it has highest potential, but especially the segments that have more data. And I would say, like, for example, in upstream, we have the reservoir engineering and reservoir simulation, which is a huge part of the upstream. And I have done my PhD at Stanford on simulation-based optimization. But now it's like, it's far away from me. I see that there's a lot more potential in drilling because we have low-colors data. We have a lot of sensors downhole and surface while we are while drilling, for example. In completion, in the unconventionals, we have a lot of data, and there's the problem of unconventional because the wells are not connected, like in the conventional reservoirs. There's a huge potential for additional developments of products and services based on data science, machine learning. In the midstream and downstream, I see friends and colleagues working on different products that, for example, tries to find, based on images from pipes, tries to find places that have corrosions, or based on the.
That we have a connection problem.
Yeah, can you hear me now? Okay, maybe.
Yeah, we lost you for about 10 seconds.
Okay, I'm sorry about that. It's probably my connection is not very good.
No,
please,
it's fine. If you can just go back to the last 15 minutes and just that would be fine.
Sure. I was telling that, for example, like I mentioned in the previously, I've seen applications of data science in midstream, people who are working on developing products that detect corrosion on the pipes based on just images that have been taken from the pipes. And so there's one thing, keep in mind, there's a huge ecosystem out there that doesn't depend on oil and gas. It's been developed, it's been developing, and it's gonna be developed even more. All these cloud platforms, just one example of the ecosystem that is out there and available for people to build products and services on those platforms. For example, the Google Cloud platform, the GCP, or the AWS, or the Microsoft Azure. I know many companies in oil and gas are now working with either Azure or AWS. And these ecosystems are out there. All these papers on deep learning, machine learning, image classification, object detection, natural language processing, and all these ecosystems for building data pipelines, going from files to databases, and from databases to creating data pipelines that give you like clean, pre-processed data. All of them are available out there, and more and more of those tools and free platforms are being available. So the industry is naturally changing. There's no stop on it. There's no going back. And so we're going to see more and more change. That's the only thing that I can say, right now. There's going to be more change, more adaptation, and there's going to be competitive advantage by companies that take on these technologies, and they become more efficient, more reliable, and some companies are going to be stay behind.
Oh, okay. Well, fair enough. Let me ask this question. So, just if you could answer it briefly. So, what's the difference between data scientist, data engineer, data analytics. If you could just cover it really short, because we heard, you know, all these three terms, you know, when we were talking. So to just make it, you know, more clarify it for our audience. So Dr. Shahab,
Sure.
Please just shortly, if you could just, you know, explain all the, you know, three different meanings behind them.
You want my opinion? There is a difference. All of these are exactly the same thing. And to be honest with you, in my opinion, even the terminology data science is being used in a very, very unrealistic fashion in our industry. And the fact that things are going to change in the future is a fact. That's very, very true. That's your the fourth question that you're going to talk about, which is very, very true. In the next 10 years, if you are not exposed in a realistic fashion, not in a sexy fashion, not in a marketing fashion, not in a joking fashion, but in a realistic fashion, if you are not exposed to AI and machine learning and learn it, then there will be a lot for you to do. And it brings you down compared to those who have a realistic understanding of the technology. And that is the main issue that in your next question, I'll be more than happy to address.
Sure. Has, what about you? I mean, do you have any different definition for these three different terms and terminology?
Yeah, I would just comment that, you know, if you look at the job descriptions, then Amazon and like in those guys post, you know, for data engineer versus data scientist, for example. For data engineer, they focus on, you know, you're going to be responsible for creating a data warehouse, you know, a SQL data warehouse, you know, where your primary job is to bring all this data from different sources into one central place. You know, think of data warehouse as a gigantic Excel file, okay, that you have everything in one spot, in one central place, you know. So that's what primarily a data engineer, you know, does. At least, again, these are based on definitions that a lot of these like companies, make. And then data science, on the other hand, focuses just primarily on machine learning and, you know, data analytics, stuff like that, you know, but they primarily distinguish between data engineer and data science, you know, when you look at these job postings. I'm not saying this is the true definition, but this is just from what I've seen, at least.
Okay. Mehrdad, what about you?
Sure. So, you know, we hire data scientists in our team. We don't hire data engineers, for example. So and we don't hire data analysts either. So the difference is that data engineer, as the name says, is about just the data, you know, building infrastructures that takes the data and does something with it, or processes, or, for example, creating databases, either tabular databases or unstructured databases, as they call NoSQL databases. So creating all the databases and providing the data in the right format for the data scientists to do what they need to do. Data scientists, by contrast, is focusing on statistical analysis and machine learning based on the data that is ready to use for them. And they want to create something of value out of the data that is in the right format in the databases that can be put to use. And then data analysts is just a lighter version of data scientists, because they typically don't work on machine learning, or they just probably do some data visualization or creating platforms for data visualizations, dashboards, and etc. Like, they typically don't need to do a lot of heavy applied statistics and machine learning. So okay. Some old people that, you know, old companies, they still hire data analysts.
Okay, so if I understand it correctly, I'll summarize it, the data engineers, they do the labors, and the data scientists, they see the concepts and they see the trends. So it's like engineers and technicians. So these are two different.
Yeah. So you're not gonna, if you have a degree, master's, PhD in a technical domain like petroleum engineering, you probably want to focus on the data science part, not data engineering part.
Okay. So let's Dr. Shahab talked about our new next question a little bit. So it's, let's say, a geoscience engineer, a chemist, overall a young professional in oil and gas, how they can kick a start with a data science or data engineer.
Okay, so one of the things I always tell people, my grad students specifically that I work with, or those who work with me at ISI, is I always tell them that if you think you are interested in AI and machine learning based, and it's all to you, it's all about mathematics behind it, then there's something seriously wrong with that. Because for all of your engineers, if you get I'm sure you probably have seen the math behind neural networks, genetic algorithm, and many of these technologies. And when you look at the mathematics behind this technology, they're very, very, very simple, incredibly simple. And you really do not need a PhD to understand them. Many people with a high school diploma can understand the math behind it. However, the problem is because we are engineers, and when we grew up as engineers, masters, PhDs, BS, we learned that in order to understand the physical phenomenon, we have to understand the math behind it. We have to understand diffusivity equation. We should be able to identify the difference between analytical solution and numerical solution. What are the different topics of numerical solution? So then at this point, when you get exposed to the mathematics behind AI and machine learning, then you say, I'm an expert. Why? Because I know exactly what's happening. That is very true. You know exactly what's happening. But the problem is you think it is all about mathematics. That is the problem. What I tell my grad student is that if you find yourself not being very, very interested in philosophy, if you find yourself not to be very, very interested in neuroscience, in biology, in human evolution, then I give you 100% guarantee that you still haven't understood anything about AI and machine learning. Because it is not only just to mathematically change one thing to another and deal with the data. You've been using Excel for all of our lives, right? So it is a different approach. When people use the two terms simultaneously, and they say machine learning and statistics, that tells you something very serious about their understanding of this technology. Because these two technology they're so different from one another. Statistics, folks, been around for more than a century. Machine learning that we understand today, it started in 1945, 46. Then it went out. It became absolutely non-existent until 1986. And then it became what it is today, started becoming what it is today. And by the way, please do yourself a favor, go through the history of AI and machine learning. Otherwise, you're not going to appreciate it. So when you do that, you'll find out that there is major differences between statistics and machine learning. Another thing that people do not get exposed to is they think if I understand how Google does machine learning in order to do image recognition, or if I understand what Google or others doing to do image captioning, which is LSTM, for those of you who are familiar with it, which is a new version of recurrent neural networks. If you think by getting exposed to that, then you become an engineer who knows what AI is, that's another way of me guaranteeing you that you have no understanding what this technology is when it comes to solving engineering problems, which is very, very different. It is not the same thing. So if you are, now what you need to do, you need to, I don't want to go into the detail of that. I teach courses that covers this. So there's not enough time to go in much more detail. One thing I can tell you is send me an email. I will send you a piece of document that I have put together. And that document is only hundreds of links that provides you, it's a sequence. It starts with human brain biology. It goes to philosophy, it goes to the history, then it goes to the mathematics, and it exposes you to what AI and machine learning is. I call it AI primer for PDA. PDA stands for Petroleum Data Analytics. So that's every student of mine starts with that. And it's something that you can't go through it in 2-3 months. It's going to literally take you years, because it is a combination of videos, articles, books, webinars, you name it. But it has a sequence that tells you the sequence you got to go through in order to get the most out of it. So I think I can stop right here for that.
Well, sure. Before I ask Haas about his opinion, is it fair enough to say if you want to understand AI and machine learning, first you need to understand how to work with data?
Exactly. It's a different philosophy and approach to problem solving. So yeah. The question I have for you, think about this. You know what everybody knows what convolutional neural network is, correct? Okay. When was it done? 2005, 2006. And it's what do? The deep learning started there. Question: when you understand what convolutional neural network is that good enough for you to use that technology to solve reservoir engineering related problem? I will be more than happy to answer that question, but think about that. Think about that.
Yeah, no, that's correct. What I'm saying, like, okay, in order to understand the whole intelligence, artificial intelligence, you need to know, I feel there is a discontinuity between the classical petroleum or geoscience and the whole concept of the data. Okay, I have a bunch of data. So how do you want to look at it? How to just understand that, just the term and the trends. So there are tools that you need to go and learn in order to just understand the data. So maybe I think everybody is like familiar with the very old Monte Carlo simulations. That was the way to look at data. So what I'm asking, like, so in order to at least we have started to understand AI, we need to understand how the data works, how it's been collected, and how it's going to be analyzed before to understanding the whole concepts and idea, and then whole artificial intelligence.
Let me give you just one sentence, and I'm not gonna go too far in that, less than 30 seconds. But this is my definition. I always say that traditionally, the way we learned engineering, what does data do for us? Data is there to serve our understanding of physics. We build the Darcy law, we build the diffusivity equation, and based on that, we need permeability. Joe, go measure it. I need thickness, go find it. I need data, because that data is serving what I understand of fluid flow in the porous media today. That is our traditional approach. AI approach is very, very different. Data is not there to serve your understanding of physics. Data is there for you to model physics. And the question is, can you model physics using data? And that's why some people talk to you about hybrid modeling, which I find it to be the most funny thing that ever has happened in our industry, by the way, which has absolutely nothing to do with science and technology. And I'd be more than happy to discuss that with you, because that is the key. The data is not there to serve our understanding of physics, data. And that, when I say data, by the way, we'll talk about that. I mean hard data, because in our industry, unfortunately, we have a lot of soft data that should not be used. we can talk about that.
Yes, that's a really different topics, but actually that's the point that what is data? That was the question. What about you, Has? What if somebody wants to kick a start with data science, data engineering, data analytics? I mean, any terminology that you think is fits. For example, let's say somebody who has a classical petroleum or geology or any geoscience education, and now, he or she feels the pressure that, from the industry, that, okay, the data science is a new concept, or data engineering. So what should they do?
Yeah, so I think the first step is to first learn the fundamentals of, let's just say you're interested in, different supervised techniques to solve a particular problem, right? Let's just say you're a petroleum engineer with 5 years experience, okay? And you understand, you're the domain expert, you understand the problem very well. And you're trying to use some type of machine learning to solve that problem, to find trends, find patterns in the data, okay? Like the first step is to learn the fundamentals of different approach. Let's just say you want to learn the fundamentals of what is a neural network and what does it do for you and when was it developed, and just learn everything about it first, And I would recommend to almost do the math by hand, almost just go through the solving the problem by hand to understand what it's doing for you first, right? Then once you understand the mathematics, and the next step is to learn how to code it, right? And you can, people talk about Python or R or Julia these days. You can use whatever you're interested in. It doesn't matter what you use, as long as you have a good capability on a programming language. You can use whatever you want to use, right, to program that in. So once you understand the math, once you understand how to code it, and also you understand the problem, then you can try to solve that problem, with that kind of approach, right? And a lot of times, some problems does not, require machine learning. You don't have to solve every problem with machine learning just because, it is an exotic term. Some problems can just simply be solved with just simple, engineering analysis. You don't have, if you have like 10 wells and you want to do comparison between two paths, you don't have the data set to do that kind of analysis. But if you have a lot of data, if you have a lot of information coming in and you're trying to truly understand the pattern of the data, then you can use machine learning, right? So my answer to that question is first, understand the fundamentals, understand the mathematics behind it, then find, learn how to code, of course, and then find a problem that you're trying to solve, and I think at the end of the day, your domain expertise will help you solve that problem. Without the domain expertise, as Dr. Shahab has alluded to, you cannot solve, you're going to have a hard time solving that problem. And I think, like in the past, I look at, for example, sometimes I look at different places and they always talk about, you got to have, a PhD in this and a PhD in that. And, I always look at it, well, first you got to have some experience in that industry. Do you understand the industry? Let's just say you're applying for a job in the banking industry. Do you understand how the banking industry works, before you can actually apply machine learning to, let's just say, find, fraudulent activities, if you don't understand the banking industry, don't have no experience in the banking industry, how are you going to solve that problem, right? So to me, I think a combination of understanding the math, understanding, like learning how to code, of course, if you haven't learned that, and then combining that with your domain expertise to solve that problem is what I recommend. I think you're muted.
Oh, sorry. Yes. Mehrdad, what about you? The question was if geoscience if a geoscience engineer, geologist, a chemist overall, someone, a young professional in oil and gas wants to kick start with data science, what's your recommendation? I know it's a really, questions that probably you have heard, or somebody has asked you before. So,
sure. What Horst said, was a good answer. I think is, if I'm a company who wants to hire a data scientist, I need two things. One is that does the candidate understand my problems? That's domain knowledge. You got to know what the industry is about. If you want to apply for a job in, say, in Chevron or ConocoPhillips, you better know what the team is focusing on. Is the team focusing on drilling, completion, or some other aspect? Or if you're applying for a job in retail, like Walmart, or if you're applying for a job in tech industry, like Apple, or if you're applying for a job in finance, say, Two Sigma, you got to know what the team is, what are the problems they're trying to solve. Do your homework, try to connect with people, understand the language of the industry and the team. Number two is that, do you have the skills to solve the problems? And the skills are now the interview questions. They're things that you need to master, either some software skills, some ecosystem, understanding of the ecosystem of data science, and a set of statistical skills. There's like Dr. Mohaghegh said, the data science is different from applied statistics. And there's a paper by David Donahoe in 2015, when I was still at Stanford. He wrote a good paper, 50 years of data science. And he talks about why data science is different from traditional statistics, and in different ways. That it's an intersection of computer science, machine learning, and IT, information technology, and the ecosystem for databases and big data analytics. So you got to understand the language of data science. And many friends called me and asked me, like, how can I get started, for example, with data science? And I've written a note in my website, my personal website, called optimalytics.com. So optimalytics is I coined the term optimization and data analytics. I call it optimalytics because it's not just analytics, it's not just optimization, it's optimization and analytics. And so optimalytics.com, my personal website, I wrote a note, it's an old note, like 2 years or 3 years ago, that I whenever a friend asks me, like, how can I get it started, I send them the link to this web page that here, just a data science 101. Here's download this data, do these things, and you get an understanding of the libraries that are typically used as a junior data scientist, a starter. The other thing is there are many online courses. It all comes for free. So go ahead and take courses in Coursera or some other platforms, on various elements of data science, machine learning, deep learning, and understand the language and techniques and the platforms. There are courses about the cloud providers like AWS, mastering AWS, mastering Azure, and these are the second step. Like you understand the ecosystem after you understand all the how to do stuff on your personal laptop using Python, R, or Java. And just one more thing is, like, if you apply for a job in oil and gas and you have a degree in oil and gas, you have an advantage because you understand the domain to a great extent. So you understand the problems now. Now you got to obtain the skills. But if you apply for a job in tech or finance, you probably don't have the domain knowledge as good as your own background.
Okay, fair enough. So we have 2 questions from our audience. So I'm gonna start with the first question. Which part of oil and gas industry did not use data science and why? I think it somehow covered that question, but Dr. Shahab?
Could you please repeat that?
Which part of the oil and gas industry did not use data science and why, or has not used?
I don't know. Sorry.
Horst?
To be honest, I'm not sure. I think like I haven't worked in every sector of the oil and gas industry to answer that question. So, but I know at least in the upstream that I've been working on the past 10 years, you know, I think I provided some examples, some of the applications that that I personally use myself, and also like I've read on the literature on some of those.
Yeah, makes sense. Mehrdad, what about you?
I don't know. Like like I said, I think every single part of oil and gas is being affected. I mean, as an industry. Okay, so you may have some problems that do not need any data science. Like you run some software, say, for example, for fracking, they run mfrac, or for obtaining the temperature in the temperature distribution in a heat exchanger, they run HISIS, for example. Okay, these softwares are out there. They still run software, so they need people who can work with the softwares. Or they do stuff like in additives, for example. They still do the additives. They need people who work with these tools and instruments. So every single part, I think, is adapting techniques. So is being affected. So still there are traditional jobs that don't require any additional skills, but I think it's like you have much wider choice for your career and for your advance if you know the techniques to move around in the data in the oil and gas industry.
Oh, okay. The second question is, how can we make connection between data science in oil and gas with other industries? Do you have any idea with your findings which other industry might use them?
Personally, I don't think so, because it has very much to do. If you're a data scientist, if your PhD is in AI and machine learning, if you are a signal processing expert or electrical engineer in computer science that has done this, then you can go to many different areas. And if it is an engineering application, then you've got to learn engineering problem that you're trying to solve, mechanical, chemical, civil, and before you can use it in a correct fashion. But so honestly, my real answer is I don't know.
Okay, Haas or Mehrdad, do you want to answer the questions, or do you have anything to add?
Could you repeat the question one more time, please?
Yeah, how can we make a connection between data science in oil and gas with other industries? Do you have any idea with your findings which other industry might use them?
I think, you know, like some industries, such as, for example, you look at real estate industry. Let's talk about that. You know, let's just say you go on. Let's just say you want to buy a house. Okay, you go on Zillow, and they have the Zillow estimate. You know, where is that Zillow estimates coming from? You know, so the real estate industry is heavily, I think, uses AI to predict price of houses based on a huge data set that they have. You know. So this is one example of using, for example, you know, AI in the real estate, you know, industry, or in the banking industry, where you have a lot of like applications, you know, such as fraudulent detection. You know, you want to find transactions that has been fraudulent. You know, like a lot of times, like I've received a phone call from my credit card company that, hey, you know, you know, you've had a fraudulent like transaction just happening 5 minutes ago. Where how was that fraudulent detection, you know, transaction? How was that captured? It was captured through probably some type of an anomaly detection technique, you know, that the banking industry uses, you know, or you talk about, you know, this is just real estate and the banking industry. I mean, you can really, it really depends on which industry like you want to take this to, but I think the applications are enormous in different industries. And as you know, like, for example, you know, you look at the entire business model of Facebook, or even like when you go on Amazon and purchase, go through a transaction, they always recommend you products. Those product recommendations comes from a lot of these unsupervised learning algorithms, that Amazon, Facebook, and those guys use. Like Facebook, for example, you go on, people think when they go on Facebook, like even when you pause on an image, when you pause on a particular topic, they're constantly recording that and know that that particular subject, caught your interest, so you can really apply, I think, machine learning to different industries, and really have some applications.
Well, yes, I mean that Amazon part is gonna like a little bit scary about this. Sometimes I think that they can read my mind. I'm thinking about a product, and then an hour later I see it as an ad on my Amazon account. I'm like, oh my God, I even hadn't typed that word. But I think the question was like, if you work for, I think this is my understanding from this question, that if you work in an oil and gas, and then if you want to move to another industry, which industries might be better, or you might fit in, as like a data science. But let me, Mehrdad, what do you think about this briefly? Because I have two more questions from audience I want to ask you guys. The question was,
I know. Yeah, it's like, I think there's no specific industry I would say that has similar problems to us. Okay, you can move around. There's the U.S. industry is heavy on finance and tech, and there are industries, the other industries like manufacturing, auto industry. The other industries are smaller. So, and oil and gas is a smaller industry compared to the giant industries that are present in the U.S. So, I would say, it's like the techniques and the skills that you master through the work that you do in oil and gas can help you get a job in a different industry, but not necessarily the applications. The applications and the problems are very specific. Okay, you can use like time series data analysis skills in analyzing, for example, time series data such as rate of penetration or the drilling parameters or the oil and gas rates or the temperature and pressure records of the sensors in the offshore platform, things. But once you go to a different industry, these signals and data are going to be quite different. So it's better to not mention oil and gas terminology when you're going to a new industry. Just try to speak their language. Otherwise, you would look like someone who is, who doesn't know where he is going. It's just, you got to know the language of the industry you are going to, and just forget about the language of the past. At least make connections, rather than speaking of the language of the oil and gas at a new industry.
Thank you. This is a question for Dr. Shahab. So there are startup companies that uses what they call physics-based data science. I know Dr. Mohaghegh has written a note in SV about it. Can you ask him to elaborate a little on that as to why does not believe in the hybrid approach? Dr. Shahab, if you could answer, if you could answer briefly, I have like one or two more questions from the audience.
This is not a brief answer, but I can give you a brief answer. Okay, so when somebody tells you I'm going to combine equations with data, you know what that means? That means I tried data, it didn't work, so I need to generate data that I know it's going to work by equations, and I'm going to do it. So this whole idea of hybrid model that is, some people call it data equation fusion. To me, the English translation of that is, I have a very little understanding of AI. Sorry, so this is how I'm going to do it. Because they have nothing to do with each other. The question that I have for you, do you think the atheism can be combined with Christianity? Do you think combining these two is going to solve the problem? These are two different things that have nothing to do with each other. They actually they try to approach the same solution with a completely, the whole idea behind using AI is to avoid equations. Why? Because equations have to do with our assumptions. It has to do with our simplification of problem solving. And you guys are all in the US most probably, so I think it's going to make a lot of sense to you when we talk about unconventional resources, right? When you deal with shale, does it make sense to build a numerical reservoir simulator? If you say yes, then it doesn't matter. There's two-part answer to that. I either do not know what shale is, or I don't know what numerical simulation is. Because these two have absolutely nothing to do with each other. Numerical simulation solves the equations that builds the physics and mechanics of fluid flow in porous media. Shale is not a porous media the way the diffusivity equation was built for. Shale does not provide you with production the same way that sand and carbonate does. And then rate transit, what is rate transit analysis? Rate transit analysis is a simplified version of numerical simulation. Remember, if you noticed a few minutes ago, I mentioned the difference between hard data and soft data. What is soft data? When you use numerical simulation, when you use RTA in shale, what do you need? You need fracture half-length, fracture height, fracture width, fracture conductivity, SRV. Question. Does fracture half-length exist in shale? If your answer is yes, then we should not continue this conversation. We have to go to a completely different conversation and talk about what hydraulic fracturing is and how does it work in a naturally fractured reservoir. So the reason these two technologies should not be combined is because they approach to solve the problem in a completely different fashion. And when you combine them, you're undoing the entire reason why you should and you want to use AI. Or the fact is you don't know why or how you should use AI. Then the equation is going to help you a lot.
Okay, fair enough. The last question is, there are startup companies that uses what they call, no, sorry, that was the question I asked. One of the biggest problems in the oil and gas industry is careless data gathering, and what we face is the huge invalid data. Can these new technologies change our measurements criteria or make a revolution in the measurement devices? Well, I start with Dr. Shahab and then Haas and Mehrdad. I know that Haas has been working on something similar like this with Schlumberger, and Mehrdad, he's working with a service company who's probably working with, gathering data. So Dr. Shahab?
Okay, so that's one of the questions I'm always asked when I do a lecture on the topic, specifically for reservoir engineers and the modelers, and they tell you, oh, we know that the measurement, the field measurements are not certain, are not exactly correct. So before I answer their question, they say, okay, how do you trust this data for AI and machine learning? Before I answer them this question, I ask them another question. I ask them, well, when you use your traditional approach, don't you use the same data? So why is it okay to be used when it has to be used very explicitly, but it's not okay when it has to be used the way it's used in AI and machine learning, which is very implicitly. So that, put it aside, we can talk about that later. But to answer your question is, AI and machine learning mimics human brain. In order to address this question, think about this. When today's Sunday, right? So yesterday you probably watched college football. Today you watched NFL. So when the quarterback throws the ball and the receiver runs and catches it, the question is, that is a trajectory data. I can give you the equation that tells you exactly based on the initial velocity that he throws and the angle, then the range where it is that the receiver could go and catch it. The question is, how many receivers in the colleges or in NFL have a PhD in engineering, that they solve that problem immediately and they go there. They don't, because human brain solves engineering related problem in a completely different fashion than engineers solve engineering problem. Human brain gets the data, but the data that human brain deals with is very, very uncertain. The guy who's running doesn't know the torque, doesn't know the initial velocity, but he sees it. So even if when you're driving and you see the red light, right? Do you know exactly your distance? No, your distance is either far or short or very, very far. But you don't know exactly how many meters and how many centimeters and how many feet it is. And then when you push so the key is human brain deals with non-exact data. Why? Because when you use AI and machine learning, you do not use data in the fashion that is used in equations. You do not need exact data. You do not need extra number of digits post the decimal point. What you need is pattern. That is why AI machine learning is capable of dealing with noisy data, with uncertain data, and discover pattern. That said, don't get me wrong. If you have some crappy data, which has always existed, it doesn't mean that's going to be part of that data too. There's a whole thing called Descriptive Analytics, which literally when we do a project, a reservoir engineering project, we spend 75% of our time dealing with the data, understanding the data, and making an understanding of what's happening before starting the modeling. That's when you take care of all that detail.
Oh, okay. Oh, thank you. Well, I just keep remembering the movie Terminator and the cyborg that was so intelligent that decided to eliminate the humans. What about you, Ha? So do you, in regards to the careless data and then, the application of AI?
Yeah, I think Dr. Shahab covered it to a good extent, but I'm just going to add and say that, one of the first steps that, I personally use before I do anything with any data is I do a lot of visualization. Let's just say you're dealing with, I don't know, completions or production or drilling data, Well, first, the first step is you do an extensive data visualization. And when I say data visualization, I mean, you can just simply do a distribution plot, okay? I have a distribution plot and, let's just say I'm working with completions like data. The range of my sand, let's just say the range of my sand per foot that I've pumped in the field, it ranges from 1,000 pounds per foot to, let's just say 3,000 pounds per foot, okay? And all of a sudden I have some points that are 10,000 pounds per foot. Well, you start questioning, are these data points valid or not? Most likely if they're not valid, then there's a problem in measurement, or it was a typo in the analysis, or when somebody was entering the information, it was a typo, So I always look at, distribution plots, box plots, just basic statistical plots to make sure you capture those anomalous bad data points prior to starting your analysis. And then once you can capture those data points, then either check the validity of those points to see if those were truly points that you have pumped or you have used, or those are realistic, or simply remove, just remove those those anomalous points to make sure they don't skew your analysis, And then once you're done so once you spend a good bit of time doing that and taking care of those issues, then you can move on to the next step,
Okay. Mehrdad, what about you? I mean, probably GE working on something, regarding these careless data or a way to, eliminate these careless data. So do you have any project on this? Do you have any answer to this question? I know you may not be able to talk about it since, it's some, related to your company, but, as you could do the best, we'll appreciate it.
Sure. I mean, sorry, honestly, I don't know exactly what the question is targeting.
The question was, one of the biggest problems in the oil and gas industry is careless data gathering. And
Yeah,
what we face is a huge invalid data. Can these new technologies change our measurements criteria or make a revolution in measurements devices?
Very good question. It's the sensors measure what they measure. Is a lot of effort on correcting bad data, and data quality assessment, I would say, is one of the major steps of any data science project. Whatever data you get is really not in the proper format in the first step. You have to, so to say, massage the data and utilize the techniques that you can understand if the data does the data make sense. As an example, the weight on bit records are negative for various values. Okay, it doesn't make sense because the proper zeroing of the weight on bit has not happened at the rig. Or sometimes in the production analysis, for example, in unconventionals, the rates that are reported in public data, like you mentioned in the drilling info, they report the data based on the data that they obtain from the production at a lease level, and they have to distribute or allocate that production to the wells that exist in that lease. So that becomes like a data quality issue. So there's a huge effort on these things, and to the best of my knowledge, it becomes like a project specific and the problem specific, and sometimes it becomes specific to the providers of those services. For example, if Baker Hughes has drilled your wells, you probably want to assess the quality in a different way, or correct the values in a different way compared to when the Schlumberger or Halliburton has drilled your wells. So it's really, there is no universal way of doing this. There are a lot of statistical techniques that you can utilize and apply in assessing the quality and like anomaly detection or unsupervised learning techniques. But these are all techniques, and it becomes problem and project specific.
Oh, okay. Oh, well, I guess this is all the time we have. We have several questions about the sources and study, guide that Dr. Shahab and Mehrdad mentioned. So would you guys share those with us, and then we'll send it to all of our audiences?
Sure.
Okay, great. Well, thank you all, and Hamid, back to you.
Thank you so much. I really appreciate all of your panelists and Dr. Khoshghadam for managing this panel discussion. Once again, I really thank all the audience for taking part to this event. For your information, a recorded version of this discussion would be available in the social media of the APPIH networks very soon. And thank you so much for attending to this session. Have a great day.
Thanks, everybody.
Thank you. Have a great day. Bye-bye.